Around 30% of the work that we do on preventive maintenance is going to be wasted. That's according to a study that was cited widely by IBM, although it's really hard to track down exactly where that study shows that statistic. That highlights something to me that Peter Drucker once said, which is there's nothing so useless as doing efficiently that which should not be done at all. That 30% was being done by people with good intentions, good equipment, good paychecks, good all that stuff, but it turned out to not be the work that needed to be done right at that minute. And that is something that makes the people who are doing the work feel stressed out, overwhelmed, not happy with their positions, not happy with the job that they have to do. And as a result, they feel like they've got this massive task that is simply thankless because a lot of the work they're doing is not done at the right time. So how do we figure out how to not only help them not do the work that doesn't need to be done, but get some of the important things that they're missing onto the calendar so they can go take care of those? My name is Jake Freewald. I'm head of product marketing here at Fulcrum, and today we're going to talk about from scheduled to smart, driving your maintenance strategy using field data and AI. And we're going to talk about both of those things very heavily because they're so closely interrelated, field data and AI. And the way that we're going to talk about that today is, first of all, go briefly over why maintenance by calendar isn't ideal. Many of you probably know this already, but I'll just make sure we level set on what the issue itself is. We'll talk about what we need to do to get past that. We'll figure out what AI-ready data looks like, because not all data is created equal. We'll talk about the real capabilities that AI has once you've got data that it can use. And then we'll talk about a practical path forward, which is probably the most challenging aspect of this because everybody's in different places and doing this practically and not just following buzzwords is really challenging. One thing that I'm not doing is talking about Fulcrum AI capabilities for their own sake. I will certainly mention them in this, but if you came here expecting a Fulcrum AI update, that's not the kind of presentation that we're dealing with today. Happy to take questions like that at the end. Happy to take any questions at the end. Feel free to enter them into the question box in your interface here. So let's start by talking about some of the preventive maintenance drivers that we've traditionally had, and they're based on metrics like the mean time to failure for a given piece of equipment. Now, if we look at the mean time to failure, then we can see that if we make sure that we're doing preventive maintenance by the mean time to failure, then we have made sure that there was no failure for at least half of the equipment, which sounds good, except of course that means that we've got a second half of the equipment, which is uncaught failures. So we do have failures for the other half. But I want to emphasize for a moment that it's actually worse than this by quite a lot. And that's because most of the work that you do in this situation is wasted work. Almost half of what you've done is done before the item was actually going to fail. No particular asset we have is the average asset. Some will hit that average, but you can't count on any asset being the average asset. So the one that you're standing in front of right now has a very high probability, almost a 50% probability of not needing to have maintenance done on it right now, which means that our timely pre-failure work is very close to 0%. That slice where we're doing it right on time is just very, very small. And that leads us to say, well, the uncaught failures is actually the biggest problem. Let me try to reduce that. But as we do that, then the amount of uncaught failures can shrink. So only 16% of our equipment has failures before we catch it. And the wasted work goes way up now to 84% because 84% of those assets will not have needed the maintenance done to it at the time that we did it. The pre-failure work that was done in a timely way, just around the time the failure was supposed to happen, is still pretty close to 0%, unfortunately. So what can we do about all of this? One of the things we can't do about it is assume that we can solve it by better calendaring. Using mean time between failures, mean time to failure, and those other kinds of metrics are not the kind of thing that are going to give us a better solution to this problem. No matter where we move that line along the bell curve, we've got failures we didn't catch, we've got work that could have been done later that we did earlier than necessary, and that's a lot of wasted manpower, time, money, and exasperation on the part of the field teams. So we need to think about what we can control, because that's all we can base our calendar on. All that we can do is what we can control, and then managing the risk. What level of risk is acceptable? Is that 16% acceptable? Is 5% acceptable? We know that actually doing the maintenance after failure is something like 10x more expensive than doing it before it fails. So that's going to, whatever that amount is going to have a financial impact, as well as, of course, the impact it has on our customers, on how regulators see us, and all that kind of good stuff. So we need to figure out what we can do to control and manage this risk. If we look at the information that's available to us, the stuff that we can control, well, we have our CMMS and we've got the calendar that we're working with all the people involved in the calendar and how we're going to book those people's time. We've got the work order backlog. So there's stuff that we know we need to do, and we hope to get to that stuff in some kind of reasonable way, reasonable time frame. And we've got field returns that give us structured data. That's good. If assuming that data is structured enough, we can use that to help us understand what looks like it really needs help versus what doesn't look like it really needs help. Maybe we inspect, which is faster, before doing maintenance, which takes longer and takes more expertise. Maybe. So those are some of the things that we have that we can help to manage our time and control risk to some extent. But there's a lot missing from that. And a lot of that stuff that's missing comes from the field worker. The field worker knows things like the bearing sounded a little different this time, or the valve felt like it was a little stiff. The corrosion was probably fine, but it wasn't quite what we would, it wasn't perfect. It just with a little bit of corrosion was probably okay. What we're seeing in this situation is a loss of signal. The information that the field worker knows is not making it into the CMMS. It's not making into the process by which we schedule people. We are not getting the baseline for how failures are occurring. We still get the mean time between failures because we're getting failures, as they happen within the environment. But those are going to hit, if you average them out, they're going to hit the mean time between failure pretty much. So we don't have a baseline for what's important about the corrosion that was probably fine versus other situations where that corrosion wasn't present. We're missing that baseline on what's acceptable and what's not. We tend to be hitting the things that we've seen most recently, otherwise known as recency bias, or maybe squeaky wheel bias, right? You see that there's a problem and you go fix that problem, and then you're constantly fighting with yourself to figure out what the next thing is that you should be doing. And finally, there's a certain amount of geographic blindness to all of this. We have a map that we can look at and we can visualize. That's one way of understanding what's going on, is we can visualize what's happening. But there's a lot that the map would need to be able to impart to us that it doesn't necessarily do naturally. Like, is the set of things that are failing recently, do they all not only happen in a certain area, but do they all come out of a certain warehouse where there are improper procedures taking place, or maybe there's more corrosion happening, maybe there's something that's not being stored correctly, something along those lines. How do you piece those things together without a person physically looking at the map, visually trying to figure out what's going on? So we get this certain amount of geographic blindness with all of this as well. What do we have to do? Well, one of the things we have to do is capture and use richer data. The information that is in the mind of the field worker that is not making it back into the into the rest of our process and the rest of our systems. Now, the field teams and the office teams have a kind of feedback mechanism, right? They know the same work orders that they're supposed to be working on. They interact with each other with regard to scheduling. They know that some of the specific metrics like MTTR that they can base their understanding of what's happening in the field, how that affects what's going on in the office. They have some of that information, and they do have some of that rigidly structured data, right? Things that they get from checklists, or that we get from some kind of a digital app that would help them capture that information. So they do get some of that structured data back. And that feedback is good, but it's limited to some extent because it's missing, again, what the technician knows. If the technician is out there working and things sound different this time than last time, we know that they in a mountainous area like you see here, there's heavy snow melt at certain times and it flooded twice last year. Well, that could have an impact on whether or not maintenance needs to happen earlier here versus later. And that you may also know about different inspections and different people having different interpretations of what's acceptable. And in that case, the information that you get from each technician may vary enough that it's hard for you as a human or an AI to understand exactly what's going on without knowing who those people were and the kinds of things that they typically note or don't note within their processes. So it's really challenging to capture this technical information, pardon me, the technician's information. Um, we try to build applications. This is one of the things that Fulcrum does all the time, right? Is build some kind of application that helps the field user understand what's going on, what they should be looking at, and helps them choose the right information in a consistent way. We do that by using things like classification sets and drop-down boxes and so on. None of the things I've described are in a drop-down. It would be too chaotic and difficult to try to get them to select a drop-down that has all of this kind of information in it anyway. They just never do it. And if they did, it would be really, really sloppy and dirty data. Even if you gave them the opportunity to use paper, they probably wouldn't write it all down, because writing things down on paper is a pain in the neck. And they're under a lot of pressure to move quickly. And they're incentivized not to spend too much time documenting. People, if you're an AEC firm, then you know this because your people are, your customers don't want to pay your people for doing a lot of extra writing stuff down. And if you're an IOU, you know that you've got a lot of strain on those personnel because they also have a lot of work to do at that time. And you want efficiency, and efficiency, writing things down on paper comes at a cost of efficiency. So that's a real challenge. And finally, of course, we want rigorous data for high consistency. So we don't want just notes to be going into the system. You need that rigorous drop-down capability in the classification sets. You need that rigorous process for most of what you do, but you still want some capability to capture this other information, which is harder to get. So what do we do about capturing that information? To start off, let's think about what AI-ready data needs to look like. If we're going to capture the data that an AI is going to be able to use, let's talk about what that AI data looks like, and then we can talk about how to capture it more effectively. First, we know that we need that rigor. I just mentioned building out an application, having drop-down boxes. That's going to help people choose one of these 4 terms instead of 4 different terms. If you feed AI a lot of different data that's similar but different, it will find patterns if you tell it to. That's just the nature of the beast. So if you feed it a lot of data that has meaningless distinctions, like they're distinct, but they're meaningless distinctions essentially, then the AI is going to pick up on a lot of things that are actually meaningless and act like it's not meaningless. Really confidently too. It'll tell you, oh yeah, I certainly see this, and yet at the same time it won't actually matter. So this is the new form of garbage in, garbage out. It's not the same thing we saw in reporting. It's not the same thing we see in traditional analytics, but it's absolutely garbage in, garbage out for an AI. We need to have observations of different types. Let's talk about that. Some of that's going to be rigorous types, like we just mentioned. Some of it's going to be the more soft kind of information, like we were just talking about. And the reason that we need that is because AI will invent things that look like they should be there. It will tell you that it sees some kind of pattern, even where that pattern doesn't really exist. It'll see something where it says, oh, there's a gap in the pattern, I'll fill that blank in. So that's one important thing, is we need as many observations as we get to give it real, honest data. And the other important aspect of this is that if you show that you completed your inspection or completed your maintenance, but you don't give the observations about what happened during those maintenance, then you're really not getting data points. You're not getting information that an AI can work on. All you're getting is timestamps. And having a series of things saying, yeah, the work was completed, the work was completed, the work was completed, doesn't tell you anything about whether the work should have been done at that time. So if we're going to move to predictive maintenance, we need to have those observations in place to ensure that we're capturing not just the timestamp, but all of the things that could help an AI figure out whether or not the work should be done at that time or not. We need to think about various kinds of dimensions, context dimensions. And this is important because the things that AIs are really good at include seeing things across a lot of different dimensions. They work like a human mind in the sense that I use the word intuitively, I understand that to be an analogy, but just like we intuitively will figure out what's happening. We don't calculate a parabola when a ball is coming at us. We catch the ball because we know how to catch a ball. That's kind of the same way that an AI works, right? It doesn't sit there and do a massive number of computations per se. It is surfaced in such a way that it kind of has an intuition about what's going on across all these different dimensions inside the data that it's seeing. So to make that a little bit more concrete, Geospatial data that we would look at on a map, to us, that's just a visualization. That's just understanding, what's going on. I can choose to put in different layers. I can take off different layers. I can have different, kinds of symbology for each of those points, or lines or polygons or whatever. But for an AI, that's data that it can consume all at once and have an intuition about. That's something that an AI has as a sense, this kind of sixth sense that we don't have, because it can capture all of it at once in an unusual way. So the more dimensions you can give it, the greater context you can give it, the better off the AI is going to be with respect to determining what should be happening, what shouldn't be happening, what advice it should give, and so on. You need temporal continuity. I just mean that you need, to have a baseline, a timeline for what's happening. If you're going to be looking at whether or not you should be maintaining a piece of equipment, you need to understand what the likely drift of that piece of equipment is from all the other assets that are just like it. And you can't do that if you don't have a baseline for what those other assets look like. So you want to know what that asset was like in 2024 and 2025 and 2026, because that's going to affect what you know about it come 2027. So having a data set that has some consistency, it doesn't have to be perfect, but it should be as much as you can, some consistency from one year to the next year to the next year, 1 month to the next month to the next month. That's going to be extremely helpful in identifying for the AI what it can pull out of that data and create information for you to use. And then finally, it needs some kind of consequence context. Like if you saw the following issues with a meter, a smart meter that you installed, but you don't then say later on, by the way, that smart meter had to be replaced, then you're not going to be able to, the AI will not be able to understand why that needs to be fixed, or maintained. The AI needs that consequence of everything that happened in order to weigh the risk of letting things happen as they happen. So all of these things are important aspects of what goes into an AI to help it make decisions that help us do what we need to do. And there's a lot that we can learn from prior attempts at doing this work, but the population statistics that we talked about at the beginning, like mean time between failures, mean time to failure, all that kind of good stuff, those are population statistics that don't know about the specific asset in front of you. Whereas if the data is there, if we have observations across time and those observations are relatively consistent and they give us all of the context about that, and we understand the consequences of what happened for each of those individual pieces of equipment and so on. If we have all of that, then the model, the AI model itself, can see what that specific asset's context is and help you make decisions about what to do about it. But it can only do that if the data is there. So let's talk a little bit more about the goals for getting that data then. One of the goals should be to ensure the rigor that's necessary for high quality data. And I can't emphasize this enough. If you have sloppy data, you will get sloppy outputs. So as much as humanly possible, we want to make things really easy for the field as they are doing maintenance or doing inspections to capture the right data very quickly and easily. Pick lists are the most obvious there, choice boxes, whatever you want to call them, yes, no buttons. Photo capture is increasingly becoming really important, and photo capture can feed later on into AI models. So if you say to someone who's doing the work, take a picture of the base of the pole and take a picture of the top of the pole, then you're going to be able to get information over time that will help you immensely with training an AI to see when there's a problem with one of those poles or one of those insulators or whatever it might be. Geospatial data should be super easy for people to capture. If you're only getting geospatial data when your GIS team is going out in the field, then you are getting much less data than you could with respect to how these different pieces of equipment fit together geospatially. You definitely need that. Integration with EAM is equally important because the EAM is the source of truth. Like we can talk about data warehouses and data lakes and anything else you want to, but the source of truth about a given piece of equipment is the enterprise asset management system. So the data that's in that EAM needs to flow into whatever your process is for ensuring rigor. You need to identify the asset itself. You need identification with the asset, not identification with the location or with the time or with the work order. Or with it. No, it's got to be with that asset, and that information comes from the EAM. So ensure rigor for high data quality. We also need to capture what I like to call the writing from the margins. Somebody's got a clipboard, they write stuff down. The more advanced workers among you who know the business more might notice things that the less advanced workers don't notice, and they will jot things in the margin. Well, that's great as far as we're now digitizing some of that and making it so it's not all paper, and we're able to put in pick lists and stuff like that for the people who are new. But how do we capture the information that wouldn't have been captured in that rigorous kind of way, the bearing that sounded different or whatever, the things that you see that we talked about earlier? That information that a 30-year veteran would know to tell the supervisor is not something that's necessarily going to be captured by the people who don't have that 30 years of experience. How do we give that, 3-year rookie or 1-year rookie or 6-month rookie the experience of the 30-year veteran? How do we give them that information? Well, we have to capture it as much as we can first in the course of actually doing the work out there in the field. Both of these things are necessary to maximize the value of AI. And that's the interesting part here, right? We need the rigor, and we need all the, I don't know what it is that's going to go into comments, the stuff that I'm not expecting to capture. All of that stuff needs to be captured, and both of those are necessary to maximize the value of AI, because AI can take advantage of both of those different kinds of data. Now, one of the first problems we have in applying AI to maintenance tasks is that we often have this kind of very fragmented environment in which people in the field are interacting with multiple different kinds of corporate systems, right? The AM is the source of truth for assets. So they've got, Maximo Mobile in the field because that talks to Maximo back at the office. And they're tracking their GIS information using Survey 123 or field maps from Esri, and they've got to use both of those together, maybe one at a time, in order to get the right information in or take the right information out. And then that's just for step one. For step two, they've got to do that again with different apps. They've got a safety step that they add in there, and so on. All of these different steps are fragmented across different apps that the user has to use. Very often, if the apps get too complicated, they will revert back to paper or spreadsheets. And when they do that, then suddenly you've gone from spending 8 hours a day in the field to spending 6 hours a day in the field and 2 to 3 hours transcribing things at home. Or you get data quality issues because the spreadsheet doesn't have the level of rigor that these apps do. The bottom line is you've got a field process that gets handled in a manual kind of way that is fragmented across different enterprise systems and across the apps that are bolted onto those enterprise systems that the field is required to use. Hugely challenging. So if you want rigor, this is not how you get it. If you want rigor, then the field has to have its own platform. And let me describe what I mean by that. The person who's responsible for GIS for the enterprise has a place to standardize their data and their processes, and that's ArcGIS. Same thing is true with the asset management leader. That person has Maximo for their data and process management for their own team, and that is their source of truth. The field needs its own source of truth to say, I'm going to take all these 5 steps that you see here, but I'm going to manage how I do them. And if I need information from the EAM, or I need it from the GIS, or whatever it may be, I'm going to pull that information into the platform at the right time, and I'm going to apply it to the right steps. And when I'm done with the steps I need to, I'm going to push it back out in a uniform way. If I have that level of uniformity, I've got 2 different kinds of rigor. I've got rigor in the data because the field is controlling exactly what the field person does, and there are fewer steps to move from one app out to another app. The field worker has something reliable to work with and is going to collect higher quality data. And that's a killer because data quality starts in the field. It doesn't start with the supervisors overseeing things. It doesn't start downstream where people are getting it and saying, oh yeah, this is bad, go back and clean it. It starts in the field. That's where it gets enforced. The second thing it gives you is process knowledge, because you understand all of the things that are happening from steps 1 through step 5. Any writing that's in the margin gets caught in step 1 through step 5. And then when an AI wants to use the information that's in the platform, it has a single place to go to get all of the data associated with the maintenance that's being done. So the rigor that you're looking for, it depends on having a platform instead of a fragmented set of field processes. The second half of the problem is figuring out how to get people to give you all of that in the margins information. And it's really challenging because they do have all of the issues: gloves, weather, live equipment, small screens, And that'll lead to a lot of abbreviations and skip notes and so on. And I'd like to mention one of the pieces of education that we got as a product company when we rolled out Audio Fast Fill. If you don't know Audio Fast Fill, please check it out. It's a capability whereby someone can speak into their phones or their tablets, and Fulcrum will capture what they say and not just do a single field like here, I'm going to put into the comments, but it will figure out which piece of the app that it's in should be filled in based on what you're saying. So it'll figure out the drop-down box has information about vegetation. And instead of vegetation, you said small tree. It's going to say, okay, vegetation. Or if you said vegetation, well, whatever. It's going to give you the right, it's going to figure out what that checkbox should have been checked based on what you said. Now, we thought originally that this was going to speed things up. People would talk into it. As they talk into it, they're focused on other things and they're able to speak faster than they're able to type. In some cases, that's true. But it turns out that a really well-designed app that's designed for productivity is hard to beat. A bunch of yes, no buttons, checkboxes, drop-down boxes. That's hard to beat for productivity. Click, 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 drop down, click. Like, okay, I can't talk as fast as I can click in that case. But what we found was that people started using Audio Fast Fill to capture information with greater richness. So whereas before, instead of checking one box off in a spreadsheet or checking off one item in a drop-down box, they would say something that could fill in a whole category of information. We have this capability to capture hierarchies within Fulcrum. So you can have a poll, here's my set of wooden poles and it's got the following characteristics and you can pick out what they are. Well, instead of somebody dropping down and picking something that's close enough and feels right, if they just talk about what they're doing or what they're seeing, it'll get to exactly the right kind of a poll in that classification set, and it will give the correct information. It'll give you richer data. And in addition, whereas comment fields are generally not used in most situations, when people use Audio Fast Fill, they tend to say things that don't have a place to go within the form itself. So we learned, right, that we designed it for speed. We named it Fast Fill. That was the point. But it turns out what it really delivers is more depth of information, a richness of information that you didn't have before. And that richness of information becomes really important because that's now recovery of the signals that we've been missing in prior situations. And that's a huge benefit to the AI, which is going to look not just at the individual data pieces, but is also going to have access to that textual information that someone spoke. One last point, of course, is that if someone speaks natively in Spanish and they speak into their Spanish, into Fulcrum in Spanish, Audio Fast Fill can translate it into English, and therefore you can capture data that wouldn't have been captured because of the linguistic characteristics of the field worker. So another way to capture signal that was being lost completely before. So we've talked a lot about good data. If we can get that richness of data, the rigorous data and the richness of the data, and have that complementary set of data, what can AI do with it? The one biggest thing that we want to look out for is the kinds of patterns that schedulers are not going to detect. Schedulers who are driven by metrics are going to not be able to see the things that an AI sees, such as, are there combinations of temperature? Maybe this is a geographic situation. Maybe there are microclimates to worry about. Maybe a bunch of different things that could be. Temperature, the rate of usage, which of course is critical, but differs from piece of equipment to piece of equipment. And age. What combination of those things will predict failure in this particular equipment class? So now I know better if I'm looking at a bunch of different transformers. Maybe this equipment class is the 72 kilowatt transformer. Maybe it's the transformer from a particular batch of transformers from a given manufacturer. It can help understand what combination of these types of factors predict failure for that class. And then you can start to schedule maintenance on those earlier. Or you might find that a particular batch was particularly good and you can schedule things much later. What kinds of assets in similar corridors are trending toward the same failure mode simultaneously? What I mean by this is the geospatial aspect of things matters here because you're rolling out trucks to take care of things. Well, where can I roll my truck to hit the most of the assets that are most likely to have issues in the near term simultaneously? right? So that I'm sending out one truck and they're going to do more in a week along this one corridor than I would if I were splitting them all up to do things on a timed basis where things were installed in different ways. And finally, you can look at the record of a failed asset. There are times when you're going to miss, right? You're going to have a problem. And when that asset fails, what did it look like prior to the failure, and what other things look like that right now? And can I track the fact that there are similarities in those situations? So these kinds of patterns, which cross so many dimensions, this is actually a really simplified version of what an AI might be able to look at. These kinds of patterns can help you change the curve. We're no longer looking at a bell curve with a mean time to failure at the top. We're looking at something that says, okay, the assets that I want to go to now are the ones that are most likely to fail. They look most like the things that have failed in the past. Let's go take care of those first. And we will get to the other ones as we move forward. As those assets get older or start to have those same characteristics, they will move up in the queue, but they'll be moving up in the queue at a reasonable time instead of being done so much earlier than they needed to be done before. We know that this is something that works because we've seen the metrics coming from people talking about emergency repairs being 3 to 5 times more expensive, 3 to 4 times more expensive than planned interventions. 95% of predictive maintenance adopters report a positive ROI. And that's of predictive maintenance adopters. That's a narrow-ish set of people. So we're seeing good work being done there, but it's not a large number of people doing it yet. 27% achieve full payback in 12 months. I think that's important, but I think it also doesn't identify the risk of failure very well. Like, people have been doing this for a long time, where they've been doing predictive analytics for a long time, but how many of those have actually failed? If they achieve full payback within 12 months, how many of those were actually, how many of the 100% that did it actually were failures in some way that was a really significant problem? 10 to 1 ROI on initial investment, same kind of question for that. Predictive maintenance market is expected to explode. I don't worry about the predictive maintenance market. I keep my eye on it from the sense that Fulcrum probably needs to provide data to other analytical tools that are going to be focused on this problem. I don't expect you or me or any individual person or group to say, okay, well, we're going to do everything with respect to predictive maintenance. I expect that this market, this $82 billion, assuming it gets that high, nobody ever seems to respond to their predictions after the fact. Assuming it gets that high, it's going to get that high because lots and lots of different people are working on it together, as opposed to an individual, one or two major predictive management platforms that come into the market. So I guess what I'm trying to say here is that I worry about AI being applied because people are saying, oh, well, you better use AI. And I think we've seen over and over again how that's a problem. It was a problem with cloud. It's a problem with, SaaS. It's a problem with blockchain, like you name it. It was a problem with the internet way back in the day. If this were a technology in search of a problem, I'd be really critical of it. And I do want to be careful about it. But I don't think this is a technology in search of a problem. This is a problem that we have that this technology might be able to be applied to in a really good way. But that doesn't make it easy. It's a real challenge to be able to do the kind of work that we're talking about doing here. Which leads to the final question: how do we get started in this kind of situation? Now, I've done something here which I don't normally do. I made it a little bit more like a checklist, a little less graphical, a little bit more like a checklist. And if you want to, you can download the slides from this presentation, and you'll see the individual bullets as we roll them out. So forgive me a little bit. I'm gonna go through some bullets, and we'll talk about that. But you can download the presentation, use that if it's useful. Let's get started. I'm going to go through 5 stages. You're probably in early stages, and you're probably in more than one stage at a time. So don't take this as in any way gospel. Apply it to your own situation. But stage 1 is normally some kind of an audit, figuring out what you've got and what you don't. How much of your field data is structured and how much of it is free form. Any company we go to, we find that they still have people using paper, and they still have people using spreadsheets. That's reasonable. Not because paper and spreadsheets are inherently better and we want to keep people to stay on paper and spreadsheets, but because paper and spreadsheets are a technology that gives rational people the ability to do things that are hard for them to do in other ways. So I don't want anybody to disparage the people who are using paper right now or spreadsheets right now, because those people have issues with, for example, an IT team that's not able to keep up with the kinds of changes that are necessary, with a set of people who are, close to retirement and who are not willing to adopt new technologies, especially not so late in their career. They're like, why would we do this? I've seen a lot of trends and a lot of fads, and let's stick with what's reliable. There's a lot of reason for using this stuff, but we do want to digitize it. I don't want to diminish that idea at all, and we do want to take the data that's structured and put it into a highly structured environment. And yet we want to capture the stuff that's free form. That may be one of the reasons that they're using paper right now or spreadsheets, because they can just throw stuff in comments and they can write stuff in the margins. So look at what data is structured and what data is free form, regardless of which kind of technology they're using, whether it's digital or paper that is being used to capture that information. Is it linked to specific asset identities? I think this is incredibly important. Like if you are looking at a GIS that doesn't have the asset identity that is the same as what's in the EAM, then you're absolutely not tracking the asset identity over time. You need to do that. Is it capturing the condition or just completion? Did I do the maintenance? Well, okay, you did the maintenance, but what actually happened during that maintenance? Did it look good to start off with? Was there some problem that you had to fix? What did it actually look like? Not just, did you get the job done? Can this information feed different kinds of tools? Typically, an analytical tool is going to be structured data, or does it live in things like PDF, spreadsheets, and paper, which is much harder to look at? An AI is going to help break those things down, don't get me wrong, but we need to understand what we have before we can start to make decisions about how to transform what we have. And very often what companies find is they discover that what they've really got is records of what's going on, but it's not good data. They don't necessarily have the kind of high quality, high resolution data that lets them understand what's happening within those asset management situations and asset maintenance situations that they're dealing with. So there's a lot to think about here. And I emphasized and maybe overemphasized the fact that no one of these things is a failure of your organization. These are the way that you have been able to do business so far, and this is the starting point for turning it into something that can be much more helpful in the future, especially to AI. Remember, we're talking about how we can help AI be more useful to us. The second stage is standardizing collection. Pretty much everybody who's working in Fulcrum right now is doing exactly this right now. On the right-hand side, I've got a picture of our public safety poll classification. If you look at it, you can see the words or the name that people see in the Fulcrum app itself, and then that could have a different value than what the name is. So that's what the second field is for. In this case, they happen to be the same. So this kind of classification where you say, I've got existing polls and it's a customer poll or whatever, that kind of hierarchy is something that's important to standardize. This helps us create controlled vocabularies, right? So your checkboxes, instead of corrosion and rust, we'll just say corrosion. Your pick lists and classification sets, all of those things can have a standard vocabulary that can be applied across multiple different workflows in the field. Having required condition fields. So the job isn't done until you tell me whether there was corrosion or not, that sort of thing. So you know that the user's not forgetting about it. Well, I should add that you only want to require things that ought to be required, right? So you should hide things that are not necessary until you see a set of conditions that then require them. And then when the conditions are right, you say, oh, well, you know what? So it's been at least 3 years since this was inspected, and I want to know whether it's got corrosion on it. Then the corrosion becomes mandated because it's been 3 years since it was inspected, right? So it's hidden until it's necessary. That's very often a good way to manage that. You need to be linking to the assets themselves. Again, it's not a GIS thing. It's not a work order thing. It's what is the asset identifier that is used in the EAM to track this particular asset, so I can track particular assets and decide when it should be maintained. I want mandatory photos at certain trigger points, both to feed the AI and help understand what's going on there, and also to help people QA exactly what's going on. You want your QA back at the office to say, hey, you know what, I'm looking at this metal pole that you've got here, and I do see corrosion, and you didn't notice it. We should have you should have done that. And then they can update the record, which of course gives you better data, which of course makes the AI more capable of understanding what's going on. Here, the use of the platform is really important, because if you can't enforce data quality consistently at the point of collection, across multiple field tasks, then it's going to be much harder to get a consistent result from any AI that you apply to it. And then finally, of course, the voice capture is important for that less structured recovery of the important signals. How do I make sure I've got different kinds of comments maybe within my app where you can have less structured information, but this part is related to the property access, and this part of it is related to the condition of the equipment that I'm maintaining. Having those different pieces of free-form text is important for that less for the recovery of important signals that are less structured. Stage 3 is building up not just the consistency of the data, but the consistency of data over time. So there's the consistency of the data across what you're doing in your organization, across the different workflows, and there's the continuity from a specific workflow across time. If you don't have a temporal continuity, if you don't have the same information over time, then what you're getting is little snapshots. And the snapshots are not going to help you understand the trends that make it possible for you to say, oh, when I see things of this age starting to show these signs, maybe it's running hot a little bit by about 3 degrees or whatever it might be. If I'm not capturing that information over time, then the AI can't tell me what the likely remaining useful life is from that trend that I'm seeing over time. It won't be able to capture that. So you need to get real information, and that means capturing a lot of information over time. Avoid capturing those little snapshots and pretending that it's data. You need continuity, not just the fact that you did it. You need continuity of the data across time. Every record, again, links to the asset identity. I've belabored that a little bit. Excuse me. The methodology that you're using has to be consistent enough to get continuity from 2 years ago compared to last week. But I want to emphasize enough, because one of the things that you will see is change in what you capture over time. What you want to do is make the changes in such a way that it's not complicated to understand what's changed, and it's not complicated to correlate what you did last week with what you did 2 years ago. So, for example, somebody who's been with your company for 30 years might say, hey, I'm going to add this additional piece of information. We really should be capturing this additional piece of information. Instead of just letting that go into your text fields, maybe that's something that should be a checkbox so that your rookie knows to check for it. So you add that checkbox into the app that you're building. Totally fine. The other data around it doesn't change, so you've got consistency, and then you've got something where there's a transition from free-form text to a checkbox. That kind of thing is consistent enough to keep continuity across the years. It's hard to do this. The discipline necessary to make sure that you're maintaining the asset identity and all of the characteristics of the asset is challenging. It's going to require that you take training a little bit. It's going to require that you do QA in the office and in the field a little bit. This is not something that's simple to do, but it's something that's necessary to do. Stage 4 is figuring out how to close the loop. So the schedulers got this information. They get the work orders, the stuff that they've always had, but now they need the field data that we've been talking about that helps them understand, and an AI, by the way, who's going to be able to understand what's going on with the schedule. They need that field data, and they need that delivered to them in a way that can be consumed by whatever's helping them schedule. It needs to be timely, because what's happening today can affect what should be happening tomorrow or next week. And we need to make sure that it is integrated with all of the information that we are also getting from the EAM, the GIS, the safety management system, and so on. We need all of those things to come together. It's not one thing, it's many. So bring together the information into the field platform, and bring the field platform information into your data lake, your data warehouse, or whatever it may be. Share the information in your field platform with these other kinds of systems so that everybody's working off the same data as much as possible. There will be variances. There's always variances between the view that the EAM person has, what the field person has, what the GIS person. Don't worry about those variances as much as you worry about the consistency that you can get from the field information that you're collecting. And this is not a rip and replace, by the way. I'm talking about integrating with, not ripping and replacing anything else. I think it's a pretty basic assumption in modern business that the person who has a responsibility for a given project or task, rather, the asset management person, is going to require a system to do asset management in. It's true with finance, it's true with customer relations, it's true with anything. So you're never going to get rid of these existing systems. The one thing that I'm suggesting here that's new is that the field has responsibility for field activities, but frequently doesn't have a platform. and that's why it needs a place to manage its own data and process, and have a place for AI to work for the field. And then stage 5 is introduce the AI when the data can support it. And that last piece is kind of challenging because really you can't apply AI too early. It's going to be working on dirty data, and then you're going to get garbage in, garbage out. So there's a limit to how early you can apply AI in any of these given situations. The stages that you're working on compound. Like I said, you're actually probably in more than one of these stages across more than one part of your company right now, regardless of what type of company you are. But the stages actually compound upon each other, so that when you do get better data collection, that gives you better data, which means you get better analysis, and that makes the data more valuable, right? It actually is one of the things that people use to fund their projects, because once people get better analysis, they say, hey, I can make better decisions. Once I can make better decisions, I want to fund the thing that helps me do that. And that means that I'm going to fund, the work that's being done for done to help digitize the field. And then by the time the AI model is ready, the thing that's actually going to target the specific pieces of work that you do. And I'm going to be honest, it's probably more than one model at some point. Don't bank on any one thing being in the model right now. We're too volatile as an industry at the moment. By the time your models are ready, the infrastructure that makes it accurate, the data and stuff that helps it understand what needs to go on, that's already being built. That's already happening. Challenging, but I think realistic to say we need the AI to be applied when the data is available for it. And by the way, data equals data itself and process data. Your data warehouse probably has the data. It probably doesn't have the process data in it. So where are we now? There's some metrics that you can look at and see where you are and where you compare. If you look at manufacturing companies, which are so much more controlled than the field is, 88% of them use some kind of preventive maintenance. And that's like, and like I said, that's just with manufacturing companies. The fact that they're still using preventive maintenance shows that the adoption of predictive maintenance is still very challenging. And that's from a recent study. It's very challenging for them to apply analytics to it. Many people have plans for it, but they haven't actually started making movements on those plans. I think part of the reason for that is that predictive maintenance is an AI specific capability, and AI has not been as powerful or as ubiquitous as it is now. So I expect that number to go up significantly. And the problem, I wrote here that the gap between what you intend and what you implement is almost always a data problem. And I think that's largely true rather than a technology problem. I think it's also a personnel problem, a political problem within your organizations. People don't feel the need necessarily to do this as much as they feel the need to do other things. So you need a field advocate saying, this is what we need to do in order to make these things work in order for this to happen correctly. So the technologies out there, the data foundation and some of the skills are what really takes to make this work. Most companies, I would suggest, are at phase 1 or phase 2 as far as actually being able to implement what they do. But we are seeing people, especially your type A companies, making much stronger leaps ahead now that AI has become so much more of a focus within their organizations. I agree with making great strides. Do it intelligently with a risk management mindset and you're not just building a better horse, you're building a car, right? You're trying to do something completely different for those organizations. I'm going to give you just a vision for AI supported and an AI supporting platform. This is about 2 minutes. I very rarely do this, but I'm going to do it in this case. I think I need to share it specifically. This is to show you what AI can do for you in the near future. Sorry, shared the wrong thing. And it's, like I said, it's about 2 minutes. You should know that the person who's speaking is an AI inside Fulcrum that's speaking to you as the listener, as well as to the field worker who is actually out there doing the work. So let's take a second to look at that.
Take a look with me at what the future holds when our field worker puts on his smart glasses with camera and microphone and gets started with his AI-guided experience in Fulcrum. We've arrived at pole 1734. Please look at the top so I can scan for issues.
Sounds good.
I've already guided him to the right power pole. Now I'll capture some information so he doesn't have to, still under his control, of course. No visible defects in insulators or other features.
I agree, log it.
I can help him remember what he needs to do.
Guy wire tension is good.
Okay, what about the guy wire covers?
Oh, right. Covers look good as well.
Got it. Ready for the poll itself?
Let's do it.
The poll tag should read 1734. It appears to be defective. Do you agree?
I agree. It's missing the 3.
Noted. Also, some cracking, but no major defects. Do you agree?
I agree. Log it. Hammer sound test.
There's more to all this than data capture. I help capture the right data with minimal effort, seeing what he sees, guiding him through the process.
Hammer sound is good. Probing below the soil line.
Just like I can help field workers with their jobs, I can keep the office informed of relevant field information.
Northern quadrant might need a second look. What's the SOP for reinspection below the soil line?
The manual says that potential defects should be reinspected and remediated within 30 days. Should I alert the office that pole 1734 should be reinspected using a shovel, along with a pole tag replacement?
Yeah, do it.
The pole's inspected, the status is logged, nothing was missed. This is the future of Fulcrum. We're creating an AI-guided experience for every field worker. Last inspection of the day, pole 1735, 50 meters northward up this street.
Metal or wood?
Metal.
Sounds good. I'm going to put my belt in the truck and walk over.
You're due for a water break too. It's 87 degrees.
Good call.
Everybody kind of laughs at that last little item where the AI is kind of mothering the field worker, but I think it's important to see that because we want safety to be a part of everything we do, and an AI who understands the safety requirements of a process as well as the technical requirements is going to be very helpful in order to get us to maintain that culture of safety. We're closing in on time. We'll have a couple of minutes left for questions at the end. Just a brief update on Fulcrum if you have not heard of us before. Significantly, we are a field process management and data collection platform. And the problem that we see that we have chosen to attack as an organization is that field teams are often struggling with inefficient tools. And those tools often cause as much frustration as they do help. And our solution to that is to provide a field-first platform. Almost everything we do is strictly about the field in conception and organization. How do we make them more productive? How do we make them happier? How do we make their work better? And how do we make the data that they provide more valuable? If we can boost productivity and streamline operations across the field, then we are going to make the entire organization, and in fact, everyone we serve, everyone that our customers serve, much happier. If you have any questions right now, I'd be happy to take them. Here's an example of a couple of different places that we're going to go to see if you're going out to IEEE or the Esri User Conference or the other two conferences here. We'd love to see you there. In the meantime, let's open up the floor for questions. And that was a change. Hang on one second. I've got a couple of questions here. Okay, one of the questions is, does your AI work offline? And the current status of audio fast fill is that it uses an LLM, large language model, which means it needs an internet connection. We are always working on the ability of what's called small language models, right? Of custom models that get plugged into Fulcrum instead, that are powerful enough to do the kind of thing that audio fast fill does, but small enough to fit on your mobile device. We're constantly working on that. I did see a demo from an engineer just the other day where another thing, it's not even out in production yet, it's in beta, called photo fast fill. I saw that work to some extent on a mobile device with no connectivity, where you take a picture of a nameplate, let's say, and it's got, is it three-phase or single phase? Is it, what's the voltage? What's the current? What's the manufacturer name? What's the model number, serial number, all the things, right? There's a whole bunch of stuff on there. And if you try to capture that information, then you're going to be typing with two thumbs, making a bunch of errors. It's much easier if you get the serial number from the EAM and then take a picture, let the AI figure out what the serial number is, and then compare the serial number to what's in Maximo. So I saw a demo of that the other day that was working on an offline model. That's not in production yet. The main product is not in production yet. I'm not saying that we will go to production initially with an offline model, but with the advances in AI right now, I would say keep your eyes open for a huge number of different possibilities. As of right this very second, that piece of what we do is online. You need a connection. Most of what we do, you do not need a connection, an internet connection to what we do. Hope that helps. If you have any questions, please let me know. Another question is, there's a lot of pressure on me to get started with AI right now, not when I have good data. What's your recommendation? This one's a little more challenging because I recognize the pressure that comes from people who say we should be using AI right now and we've got data, so go look at it. But at the same time, garbage in, garbage out. So I would suggest that you start using AI to help you do whatever phase you're in. Like if you've got a phase, if you're phase one, you're doing an audit of what needs to happen. AI is very good at sorting out different pieces of information from unstructured data, let's say. Maybe you're collecting a lot of stuff in spreadsheets. Maybe you've got a lot of paper being transcribed. Whatever the case may be, if you can feed in some way that information into the AI can help you do the audit, which will highlight things that you should specifically be capturing. I see a lot of I see a lot of these specific characteristics in a particular type of pad-mounted transformer. I see a lot of failures happening when it seems like this, one worker team has said that it wasn't, that everything was okay. So maybe that one worker team needs some re-education, some training, all of those kinds of information that you can glean from the documentation you have without you actually having to go through all that documentation yourself in such a painstaking way. AI is not really built for the field most of the time, but in this case, the audit aspect of it, summarizing, the summarize email aspect of, or summarize my meeting aspect of AI can be applied to summarize my junk data that's in an unstructured format and give me some real information that I can pull back. AI could be pretty good at that. And then finally, I've got only one more question. So if you've got anything else, please throw it in there. How is this different from prior attempts at moving to predictive maintenance? That's a great question because a lot of the fundamentals are the same. The things that we are doing are literally the same kinds of things they were doing 15 years ago, in the sense that they're taking a large quantity of data, they are analyzing that data, and they are trying to figure out which things look like the stuff that used to fail. How do I get those things scheduled earlier? That aspect of it really hasn't changed. That's what predictive maintenance is. But as compute power expands, as the price of collating information drops, as the price of analyzing photos drops, as the cost of all these things come down, that makes it possible to do things that were not possible to do before. I just mentioned that developer that I saw the demo of the small language model working on Photo FastFill. That model was something that he was able to train for something like 25 bucks. Now, he's got knowledge that I don't have, so I don't know that I could train the same model for 25 bucks, but one of the things he's talking about doing is making it so that you can take a Fulcrum data set and train an AI model on that Fulcrum data set. And you just have to say, this is the data I want to look at. Now go figure, take a look at it for yourself and see where the anomalies are, see where my sanity checks should be, all that kind of good stuff. So as the price of creating a model drops from a couple of clicks of a mouse and 25 bucks, drops to that from having really highly paid AI specific developers and a lot of horsepower and a lot of money. As it drops from that to a couple of clicks and 25 bucks, I think you're going to see the advances in predictive maintenance moving much more quickly than they ever did in the past. We're right about at time, and we're right about out of questions. So I appreciate your time today. Thank you very much for spending time with me. I know that you had other things you could do, so I appreciate you spending the time today. Come to fulcrumapp.com to get any more information. Thanks very much.